This video focuses on some of the available heat exchanger models on VapCyc that are evaporator specific. These include the 3600 watt water-cooled heat exchanger, the generic heat exchanger with latent load, the water-cooled ice evaporator, and the alpha 1240 watt CO2 to AC evaporator. The 3600 watt water-cooled heat exchanger is a tube-in-tube heat exchanger. Under the Heat Exchanger Parameters tab, the number of segments, location of the primary fluid, and a secondary fluid can be specified. Underneath, a user can input tube geometry and characteristics such as total tube length, inner and outer tube diameter, material thickness, and material conductivity. On the right side, a user can input secondary fluid mass flow rate or volumetric flow rate, and select a fluid state specification, whether single-phase or two-phase, and enter the values below. A secondary loop can be specified if wanted, and this gives a user to specify loop inputs and guess values for this loop. On the side, there is a little folder called Secondary Fluid where an external user-defined DLL file can be uploaded. Under the Fluid Correlations tab, choose the heat transfer correlations and pressure drop correlations for primary and secondary fluids, as well as void fraction correlation for both, if needed. The generic heat exchanger with latent load is very similar to, and is essentially an extension of, the generic heat exchanger model from the first heat exchanger video. However, in addition to the generic inputs, the latent load model includes inputs for air inlet wet bulb temperature, air volume flow rate, wet fit efficiency, and air side area on the Heat Exchanger Properties tab. There are no pre-sized capacities available. The Materials Properties tab is identical to the one of the generic heat exchanger. The Heat Transfer tab allows heat exchanger coefficients for both the air and the refrigerant sides to be entered, with the only difference being that you cannot specify the refrigerant liquid heat exchanger coefficient. The water-cooled ice evaporator is a simple UA-based single-segment model. There are two tabs for modifying parameters. Under the Heat Exchanger Properties tab, the number of heat exchangers in parallel, tube geometry, tube thermal conductivity, and water temperature can be inputted, with the option to change between different types of units for all. The Heat Transfer tab requires the input of water and refrigerant heat transfer coefficients. This time, the liquid, two-phase, and vapor refrigerant heat transfer coefficients can all be specified. The alpha 1240 watt CO2 to AC evaporator has a similar if not identical edit properties window as the generic heat exchanger. User can define their own values under the Heat Exchanger Properties tab, and above, pre-sized capacities are available. Material properties such as tube and fin, material density, and cost can be entered under the Material Properties tab. And heat transfer coefficients for air and refrigerant sides can be entered under the Heat Transfer tab. For more information on the following heat exchanger models, please refer to our first video on VapCyc heat exchangers on our Optimized Thermal Systems website. And for more information on these heat exchangers, please refer to our second video on VapCyc heat exchangers, also on our Optimized Thermal Systems website.